Today we are going to discuss about CAN formats. There are two types of CAN formats available. One is CAN 2.0A, which is a standard frame format with 11-bit identifier, and the other is CAN 2.0B, which is having 29-bit identifier, and it is known as extended frame format. The standard CAN message frame format uses 11-bit message identifier, that is it is actually CAN 2.0A, which is sufficient for use in regular automobiles, that is for most of the automobiles that can be used CAN standard frame format. But for some other vehicles, trucks, off-road vehicles, we require some extended format, that is having a 29-bit identifier. So the Society of Automotive Engineers (SAE) Truck and Bus Control Communications Subcommittee had developed a family of standards concerning the design and use of devices that transmit electronic signals and control information among vehicle components. We know the Bosch developed the standard frame format of CAN in 1980s, but for the use of trucks and other off-road vehicles, we require some better standard. That is why we are going for another standard, that is known as an extended format, CAN extended format. We know the standard frame format. This is the standard frame format with 11-bit identifier, 0, 1, 2, 3 like that, and this is the MSB, most significant bit, and this is the start of frame. This is the start of frame that we have seen in the CAN class. We have seen that in the CAN lesson, and here so the first bit will be a start of frame, and it is a dominant bit, that is we are giving 0, that is an indication of a start of frame, and again 11 bits will come, that is 11 bits will come, that all are the identifier for standard frame format. So these are the 11 bits, 1, 0 like that, 1, 2, 3, 4, 5, 6, 7, 8 and plus 3. So these are the 11 bits of node 1, 11 bits of node 2, 11 bits of node 3 like that. To have a better application for the off-road vehicles, the CAN standard needed to be enhanced to support 29-bit message identifier, that is extended format has 29-bit message identifier, but standard frame format consists of 11-bit message identifier, and ISO 11898 amendment for the extended frame format CAN 2B was introduced in 1995. We know the basic CAN structure was introduced in 1980 by Bosch, but the extended frame format was introduced by Society of Automotive Engineers in the year 1995. The 29-bit message identifier consists of the standard 11-bit base identifier and the 18-bit identifier extension. That is, 29-bit identifier consists of the standard 11-bit plus 11-bit identifier extension. The distinction between CAN base frame format and the CAN extended frame format is accomplished by using the ID bit inside the control field. That is, there is an ID bit is there inside the control fields. This frame format is divided into different fields. So one of the field is the control field. So in the control field there is an ID bit. So by choosing this ID bit in a proper manner, we can decide whether it is standard frame format or extended frame format. A low means dominant. Low ID bit indicates an 11-bit message identifier. A high means recessive. ID bit indicates a 29-bit message identifier. So here this is a standard frame format. So this is the start of frame. Then this is the identifier. This can be 11-bit identifier. Up to here, both frame will have same structure up to identifier. then this is the ID. So this is low means it is a standard frame format, and high means it is an extended frame format. Again, there are another fields in the standard frame. Another fields are there in the standard frame. One is the ID that we know to check whether it is standard frame or extended frame. Then DLC, data length code, then data field. So data length code means DLC 0 to DLC 4. So it is a 4 bit. So you can see 0 0 0 0. So if it is 1 bit, it will be DLC 0 will be 1, all other bits will be 0. So only 1 byte will be there in the data. If there is 2 bytes in the data, it will be 2 1 0. 2 bytes will be sent in the data field. So this is the blue, this is the data field. So 2 bit will be in the data field. If it is 8 bytes are sending, you can see 8 bytes are sending 1 0 0 0. So we are sending 8 bytes, 3 4 5 6 7, 0 byte 0 byte 7. So we are sending 8 bytes in the data field. So this is the data length code, then the data field, then the CRC, cyclic redundancy check, acknowledgement, like that, end of frame. So 11 bit identifier, standard format allows for total of 2 raised to 11, that is 2048 different messages, and 29 bit identifier, that is extended format allows a total of 2 raised to 29 messages, approximately 50 million, like that. It will be comes around 500 millions or 50 millions. I don't know the exact value. Both formats, the standard format, that is the 11 bit message ID, and the extended format, that is having a 29 bit message ID, may coexist on the same canvas. That is, it can exist in the same canvas, but we are deciding which is to be used based on the bit in the ID bit. That is, we have seen in the previous slide, there is an ID bit is there, ID bit. Because of that, that is the identifier extension. ID stands for identifier extension. So based on that identifier bit, we can decide which is the standard frame format, whether it is standard frame or extended frame. So standard frame having 11 bit message ID frame, and extended frame will have 29 bit ID frame. That is, both will coexist on the same bus. During bus arbitration, the standard bit message, standard 11 bit message ID frame will always have higher priority than the extended 29 bit message ID frame with an identical 11 bit base identifier than gain buses. So for assessing the bus, this 11 bit message ID frame will have the priority. We have seen the priority arbitration in the CAN class. We have seen that in the CAN structure. So this may occur, this CAN extended format as well as CAN standard format may occur in the same CAN itself, but we can decide that whether to use CAN standard or CAN extended based on the ID bit. So here you can see the control field, the DLC, this DLC, here there is a DLC is there, DLC 0 to DLC 3. So this DLC 0 to DLC 3 will come here, DLC 0 to DLC 3, here you can see DLC 0 to DLC 3, and the next field is the data field. So here you can see the DLC field will come in the control field, and the next field is the data field. You can see here, this is the next field is the data field, this is the control field, the DLC field is the control field. So the extended format has some trade-offs. The bus latency time is longer, minimum 20 bit times compared to that of the standard frame format, and the messages in the extended format require more bandwidth also, because more data is there. That is, the bandwidth is about 20% higher, and error detection performance is also reduced in the extended format. This picture shows the control field of a CAN data or remote frame according to the original CAN standard. Original CAN, this is the control field of standard frame format. The first one is the arbitration field. Arbitration field means the 11-bit identifier, and like that. Then the next is the control field, and the next one is the data field that you can see here. This is the identifier, then RTR and IDE that we can see later, then the DLC, then the data field. That is, the DLC stands for the data length code, data length. That is, if the data is having 8 bits, it will be 1 0 0 0. If it is 7 bits, this is 0 1 1 1, like that. So this is the control field of a standard frame format, and in the case of extended format, this control field is changed like this. The control field will be changed like this. This is the DLC, and again this is the control field. This is R0. This is the ID. This is the ID. So this will decide whether it is extended format or standard frame format. You see the standard frame format. So here this is R1 and R0 that was used for future use. That was reserved for future use in the standard frame format. But in the extended frame format, it will be like this. The changes. One is again reserved. The other one is the R0 identifier extension, IDE. IDE stands for identifier extension. If it is 0, it will be if it is 0, that is, if it is dominant, it will be a standard frame format, and if it is recessive, it will be an extended frame format. So in the extended frame format, the control field was redesigned, that is CAN2B, as shown in the picture below. That is, we have changed it to IDE. R0 and R1 was changed into R1 is changed into IDE in the picture below, in order to support coexistence of 11-bit and 29-bit message identifiers on the same CAN bus network. Here there was a space. A low dominant IDE bit indicates 11-bit message identifier. ID, if it is low, it is a 11-bit message identifier, and a high recessive, means recessive IDE bit indicates a 29-bit identifier. So here this is the standard frame format with the 11-bit message identifier. This is the start of frame. This will be always dominant, that is a low. This will be always dominant, that we have seen. And again the 11-bit identifier. This is known as the arbitration field. This is the 11-bit identifier, and this is the first one is the MSB. And this is the LSB, and this is the IDE. IDE stands for identifier extension. This is R0. All these will come in the control field. This is the DLC, data length code. That is, it can be from 0 to 8. That is, it will be a 4-bit code. Data length code is a 4-bit code. So here this is the extended frame format with 29-bit message identifier. Again, similarly here also start of frame. This is the start of frame. This is dominant. Again 11-bit message identifier. Then the IDE, which will decide whether it is standard frame format or extended frame format. Then again 18-bit identifier, and so it is totally 29 bits. So the MSB will come here. Previously MSB, that is the MSB of the 11-bit identifier came here, but here the MSB of the 29-bit identifier will come here, and the LSB will come here. Again the data length code R1, R0, like that. This is the control field. So there is a change in the control field, you can see. And again a low dominant IDE bit, a low IDE bit. If the IDE bit is low means dominant. indicates 11-bit message identifier that you have seen, and high, that is recessive ID bit, indicates a 29-bit identifier. And here you can see that identifier extension IDE bit belongs to control field in the standard frame format, that is it will goes to control field in the standard frame format. That you can see here in the standard frame format, IDE bit will come in the control field. IDE bit will come in the control field, that is in the standard frame format IDE bit will come in the control field, and in the case of extended frame format IDE bit will come in the arbitration field, that is here the IDE bit will come. IDE bit will come in the IDE bit will come in the arbitration field in the 29-bit format. That is actually this is the IDE bit will come in the same position from left. The IDE bit will come in the same position from the start of frame in both standard frame format as well as in the extended frame format. That is after arbitration field. This is in the case of standard frame format. From here onwards control field starts. So that is why in the standard frame format IDE bit will come in the control field, but in the case of extended frame format, this bit will decide whether it is standard frame format or extended frame format. If it is extended frame format, again 18 bits will come. Again 18 bits will come. So this will come, IDE bit will comes in the arbitration field in the case of extended frame format, but it will come in the control field. That is, you can see it will come in the same position in both. IDE bit will come in the same position from start of frame in the standard frame format as well as in the extended frame format. So this bit will decide whether the next bits are control field or belongs to the arbitration field. So if it is low, this will be the control field itself. If it is high, these bits, the remaining coming bits will be the extended field. So that is why this IDE bit will belongs to control field or the arbitration field. So in the case of extended frame format, IDE bit belongs to the arbitration field, and in the case of standard frame format, IDE bit belongs to the control field. So that is explained here. So the control field of the IDE bit belongs to the control field of the standard frame format, the arbitration field of the extended frame format. And a 29-bit message identifier consists of standard 11-bit base identifier and 18-bit identifier extension that we have seen. Between SOF, the start of frame bit, and the end of the 11-bit base message identifier, both frame formats, standard and extended, are identical. That is, up to the end of 11-bit base, both the standard frame format and the extended frame format are identical. Now we can see what are the difference between standard frame format and extended frame format. The following 11-bit base identifier, that is following 11-bit base identifier, this is the SRR here, SRR, that we can see what is it. And here in the standard frame format, after 11-bit identifier, it is RTR in the case of standard bit identifier, and in the case of extended format it is SRR. So what we can see, what are the values? So here following the 11-bit base identifier, the extended format uses an always recessive, that is always recessive, always high SRR substitute remote request, SRR, that is the full form of SRR in the extended format. SRR always, this is always recessive, always high, this is always high, recessive, always recessive, always recessive. and it is replaces the regular RTR, remote transmission request. That is, in the case of this one, this is RTR. It was SRR in the case of SRR in the case. It was SRR in the case of extended bit format, but it is RTR, remote transmission request. In the case of standard frame format, it is SRR here. SRR is actually substitute remote request, and in the case of standard frame format, it is remote transmission request. That is, the following IDE identifier extension bit. The following IDE bit is also kept at the receive level. That is, we can see with the use of recessive SRR plus a recessive IDE bit, that is, both are high, recessive IDE, and this is also IDE. This is also recessive. IDE is recessive, SRR is also recessive. Recessive means high value. High value means recessive. Low value means dominant. So here SRR and IDE both are high value, will determine with the use of recessive SRR plus a receive IDE bit. It is guaranteed that standard message format 11 bit standard message format will be having higher priority than extended format. That is, the extended format means compared to standard frame format, extended format will have lower priority. So normally standard frame format will dominate compared to the extended frame format. So that is decided by the value of the SRR bit, and the value of the IDE bit. The value of IDE bit and the SRR bit will decide whether it is a standard frame format or the extended frame format, and it will dominate. That is, the standard frame format will dominate compared to the extended frame format. Then what are the difference between the standard frame format and extended frame format? You see the control field of the extended frame format. This is the extended frame control field of the extended frame format. Again DLC is there, 4-bit DLC is there in standard frame format and extended frame format. This is the control field, and again R0 and R1, 2 bits are reserved for future use. This is the arbitration field, this is the control field, data field. So we can see the comparison of the control field and the comparison of the data control field of 11-bit extended 29-bit extended format. So this is the control field of the extended format, that is R1, R0, these are reserved for future use, and this is the data length code DLC 4-bit. And you see the control field of standard frame format, DLC is there, R0, here IDE is there. So IDE, so this is the IDE. This may change to depending upon the value of this IDE. This will move from here. That is, if you are using an extended format, here after this again our arbitration field will come. So IDE will come in the arbitration field in the case of extended format. IDE, after this IDE, if it is extended format, again the next part of that is 18-bit will come, then the control field will come. But here, as it is a standard frame format, the IDE will come in the control field, that you can see here. It is here the IDE, again the control field. So the difference between the control field in the standard frame format and the extended frame format is, here in the standard frame format it is IDE will come in the control field, but in the case of extended format, R1 and R0 will come in the control field, and R1 and R0 is used for a future use, but IDE will come in the arbitration field in the case of extended format. So you can see the control field of an extended message frame following the 18-bit extended identifier plus RTR bit has the format of the original CAN2 standard. Bits R1 and R0 are reserved for future use and are kept always at a dominant level. It will be kept always at a dominant level. So this is the standard frame format. This is the start of frame, 11-bit identifier, remote transmit request, IDE, R0, data length code, 8 bytes of data, cyclic redundancy check, acknowledgement, end of frame. All these are the fields in the standard frame format. Now we can see what are the fields in the frame. SOF stands for start of frame bit. It marks start of messages. It is used to synchronize nodes on the CAN bus. These are the functions of different bit. Start of frame. Start of frame means start of frame bit. It marks as the start of a message. That is, it is always dominated. That is always dominated. A message start with a dominant bit. That means a low bit. It is used to, that we have seen here. We have seen this is the start of frame. It is always starts with a dominant. This is the dominant, CAN high and CAN low. This is the dominant that we have seen. So this is the start of frame. The second bit is the identifier. That is 11 bit. In the case of standard frame, it is 11 bit binary in size, and it establishes priority of message. Lower the value, higher the priority. That we have seen in the CAN class. The lower the value, the higher the priority. Then the RTR, it stands for remote transmission request bit. This field is dominant when node requires information from another remote node. All nodes receive request and all the nodes receive reply. All the nodes will receive request and all the nodes will receive reply. Specific node process the request based on the identifier and transmits the reply. Then the next bit is the IDE. So this is the identifier extension bit. So which decides whether it is standard frame or extended frame. That we have seen. Then the next bit is R0. It is reserved for future use. And the other bit is DLC. Stands for data length code. It is 4 bit in size. That we have seen. It indicates the number of bytes to be transmitted over the CAN bus. Then another one is, the last one is the data. It contains up to 64 bits of application data. That is, it contains up to 8 bytes. 8 bytes means 8 into 8. So 64 bits of application data. Then the next is the CRC. It is used for error detection and correction, and it is 16 bits in size. CRC 16 bits in size, and the next two bits are ACK. This is 2 bits in size, and actually this is all nodes receive the data. All nodes receive the data sent by the sender. So the node corresponding to the correct receiver will updates its value in the acknowledgement field. That is the use of this acknowledgement field. And the next is the end of frame. End of frame means it indicates the end of a data, end of a frame, and it is 7 bits in size. It marks end of the CAN frame or the message. That is, it will indicate the end of the CAN frame or the message. And the next one is the IFS. IFS stands for interframe space. Interframe space stands for between two frames there require a space, and it is actually 7 bits in space, and it is similar to our buffer. That is, it contains time required by controller to move correctly received frame to proper position in the buffer area. That is actually it is similar to a guard band in our TV transmission, like that. It is between frames. Between two frames, we are using an interframe space, that is 7 bits in size. All these things are about the standard frame format. That is all these bits corresponds to this, as well as these bits corresponds to the standard frame format. In addition to the standard frame format, the extended frame format will consist of some other bits also, that we can see in the next slide. So here you can see the extended frame format, that is starter frame, 11-bit identifier, SRR, IDE, 18-bit identifier, again RTR, R1, R0, DLC data length code, 8 bytes of data, cyclic redundancy check, acknowledgement, end of frame, interframe space, IFS. All these are the fields in the extended frame. Some other fields compared to some more fields compared to the standard frame format, that we can see what are the extra fields in the extended frame format. That is, you can see here SRR, it was RTR. There was no SRR in the standard frame format. There was no SRR in the standard frame format. In the place of SRR, it was RTR in the standard frame format. But here RTR is there, but it is at a different position. RTR is at a different position. But in the case of standard frame, it was in the case of in the position of SRR, RTR was there. But RTR is there in the extended format, but it is at a different position, that you can see here. RTR is here after 29-bit identifier. RTR. But in the case of standard frame format, 11-bit after 11-bit identifier, RTR is there. So in the position of this RTR, this SRR will come. So we can see what is SRR. SRR, it stands for substitute remote request. It replaces the RTR bit of the standard CAN frame message location as a placeholder in the extended CAN format. That we have seen. That is, in the place of RTR bit of the standard CAN message, it is replaced with SRR in the extended message. Then the IDE, it functions as a receive bit in the identifier extension. That is, there is an identifier extension is there. It indicates that more identifier bits are followed. That is, 18-bit extension follows the IDE. That is, if it is high, if IDE bit is high, the identifier is having 29 bit. If the IDE bit is low, it is having only 11-bit identifier, or it is standard frame format. Again, there is an R1. It is additional reserved bit value for future use. All these are the extra bits in the extended frame format. In short, we can see the difference between standard frame format and the extended frame format. This is the standard frame format, and in the standard frame format, after identifier, there is an RTR is there. After the 11-bit identifier, there is an RTR. This is after the 11-bit identifier. This is the arbitration field of the standard frame format. But the arbitration field of the extended frame format is this up to this. The arbitration field of the extended format is up to here, but the arbitration field of the standard frame format is up to here. So in the case of the standard frame format, here an RTR bit will come. In the case of extended format, here an SRR bit will come, and there is IDE is there. But here the IDE corresponds to standard frame format. IDE corresponds to the control field, but here the IDE corresponds to the arbitration field. The IDE corresponds to the arbitration field. Here the IDE corresponds to the control field. then this is the standard frame format. This is correspond to the extended frame format, that is R1 R0. So the change is here in the control field as well as in the RTR field. No other change. CRC, ACK, all these field corresponds to the both the standard frame format and extended format will have same values. So this is regarding the CAN frame format. That is, by looking into these two figures, you can clearly understand the difference between the extended frame format. This is the extended frame format. That is, the mainly the ID bit will come in the control field in the standard frame format, but ID bit will come in the arbitration field in the extended format. Here in the place of RTR, SRR will come, and RTR will be there, but that will come here. So that is the difference between the extended frame format and the extended frame format and standard frame format. So these are the CAN frame formats.